Hello everyone. So I'm gonna give you some hints on this number 4 assignment. So hopefully everybody's doing some readings during the break and doing some catch-ups. Okay. All right. So first question is simple. So it's a conditional probability. It's actually all all of the information is given here. So no parking zone and get a ticket is this probability, and the probability that you can't find legal parking space and is to park in the non-parking zone is 0.2. So this is a conditional probability. So what you can do is this. So you can define basically two events. So for example, let n equal to parking in no parking zone, and you can let t equal to getting ticket. Okay. So you can always define something. This is A or B, whatever you want. Okay. So now you can use the formula for conditional probability, and the formula for conditional probability, as we give in the class, is this: PA with the condition that B has occurred equal to P A and B over P B. Okay. So in this particular question, of course, it's basically, in our case, is P T under no parking. So when you park on the condition, what's the probability of getting a ticket parking at a no parking zone? And PT and PM, right? So you look at this one, what are the given, what are not given? Apparently P of n is given over here, PTN and, right, which is this one, which is and. So that's actually all given. So that's the first question, very simple. Okay. Yeah. Let's take the second one here. So it's also a conditional probability. Okay. Now this question gives you a table. There are female doctors and male doctors. Okay. Each category is doctors, pathologists, pediatrician, and psychiatrician. Right. So first, choose one doctor random. Find the probability of a male if given the condition is a pediatrician, and also find the probability of a pathologist if it's a female. And asking the question, are the events female and pathologist independent, and explain why. Okay. So the first thing that you can do is calculate the total number at here. Right. So that's total number. This is a very similar question as the midterm question here. Right. So then we can calculate the first one, part A here. Right. Part A, conditional probabilities. Then which category we're giving this one here? This is assuming this is occurred, right? This is occurred here. Okay. And asking the female percentage of that probability of this. So apparently, you look at that, what's a female? This is the number of female here, right? And that's the total number of pediatrician there. Okay, so apparently the first part A, right? The first part P male this, right? Equal to what? 33,000, and divided by 33,000 plus 33,351, right? Okay, yeah. Second one, it's the same matter. Pathologist, male. So given this is a female, right? Under the female here, what's the probability of being a pathologist? So apparently, what's going to be is, right, pathologist. Okay, under female equal to what? 56,004 divided by the total number over here. Okay, yeah. So that'll be this one here. So the frequency of happening. C, yeah, this is a part you need to understand the concept correct. Are the events of this and that independent? Now in the class we said let's see if what's the independence. Basically, you have A and a B here, right? We said A and B, right, equal to PA and PB multiply. Okay, so this is basically the so-called necessary and sufficient condition for, right, for independence, right, for, okay, so what means is you need to calculate this, calculate this, see if they're the same. If they're the same, that means they're independent. If they're not the same, they're not independent, right? Okay, so that's why we are doing it. But in this case, I think we're going to do it a little bit differently. So let's say if you do this way here, what would you do, right? So let's say now PA here represent, let's say A represent a female, B represent a pathologist, right? So you need to calculate the probability of being a female and the probability of being a pathologist. And that's fairly easy. Probability of being a female, so this total number divided by, so let's see, this is F total, and this is M total. Okay. So what you need to do is being, so P female, right, equal to F total, and divided by F total plus M total, right? So that's this one here. And being P pathologist, and that's basically the number of total pathologists, these two here, and divided by the total number adding up here, right? Okay, so that's PAPB. So what about PA and B? So P female and pathologist. Okay, so this one here, and you need to what do you need to calculate here, right? What do you need to calculate? So it's female and pathologist. So what we need to, let's take a look at this one here. It's female and, so basically, what's the number here, right? It's female and pathologist, yeah. So it's this number here, right? It's this number, 5604, and divided by the total number here. Okay, so compare if this equal to that multiplied by this. So that's one way of doing it. Now the other way of doing it, right? The other way of doing it is what? The other way of doing it is this. Now using this conditional probability. Okay, so conditional probability in the class we mentioned of this, right? PA and B, okay, equal to PA. Okay, if A and B are independent. So that's quite easy to understand because, see, I mean, if A is not dependent on B, then apparently the conditional probability here would be reduced to the probability of A here, right? Yeah. So let's see, right? Let's see if we can get this thing here, right? And let's see if I use A represents as a pathologist, and B is a female. Okay, so as a matter of fact, I think you calculate that in the part B over here, right? You calculate the part B over here. Okay, so this is from part B. Okay, and then you compare that with the probability of a pathologist. See if they're the same. If they're the same, right, then that means they're independent. Okay, and if not, then you can conclude that A and B are not independent. Okay, so that's this question here.